So you've almost certainly used a tool like ChatGPT, right? Maybe it helped you write an email, or maybe it answered some super random question for you. And it feels kind of like magic. But what's the engine running under the hood? In this explainer, we are pulling back the curtain on what we call large language models, or LLMs, to show you how they actually work. I mean, it really does feel magical. You type in a question, and boom, out comes this perfectly formed answer. But it's not magic. What you're seeing is one of the most powerful and maybe one of the most misunderstood technologies of our time. So let's break it down and see what's really going on inside that black box. All right, first things first, what is an LLM? The name itself, large language model, gives us a few clues. And as you're about to see, this technology is a quantum leap beyond that simple autocomplete feature you have on your phone. Okay, so at its core, an LLM is a very specific kind of AI. Its whole job, its entire reason for being, is to process and produce human language. And the key word here is trained. It's been fed an unbelievable library of text. We're talking a huge slice of the internet, countless digital books, articles, you name it, all to learn the patterns, the structure, and the subtle nuances of how we humans talk and write. You know, to really get the difference, just think about the autocomplete on your phone. You type "see you" and it suggests later. Pretty useful, right? But it's small scale. An LLM takes that basic idea and dials it up to 11. You don't just get the next word. You can give it a big command, like write a professional follow-up email, and it spits out the entire thing. And that power goes way, way beyond just writing emails. We're talking about the same core technology being able to draft an entire essay, translate Japanese into Swahili on the fly, or even write the actual computer code that makes a website function. It's got to be one of the most versatile tools we've ever built, which of course leads to the big question. How in the world does it learn to do all that? Well, the process is way less about just memorizing things and much more about developing a kind of intuition. So to get our heads around this, let's use an analogy. Let's imagine the LLM is a digital brain chef. Okay, so this is the crucial point. Our digital chef doesn't just memorize every single recipe in a cookbook. That'd be like trying to memorize every sentence on the internet. It's just not practical or very smart. Instead, it reads, basically the entire world's cookbook to learn the fundamental principles of cooking itself. So you can think of its training in 3 steps. First, our chef learns about ingredients, which words and ideas taste good together, like peanut butter and jelly. Then it masters the techniques. That's the rules of grammar and syntax, the how-to of building a good sentence. And finally, it gets meal structure, how to combine sentences into paragraphs to build a coherent story or a logical argument. So where does our chef keep all this culinary knowledge? It's not in a recipe box. It's stored in billions of what are called parameters. You can think of these like tiny little connections in a brain, or maybe like billions of little knobs. Each knob represents a tiny learned relationship between different words and ideas. And the sheer number of them, we're talking billions. That's what gives these models their incredible depth. Okay, so our digital chef has learned all the principles of cooking. But how does it actually whip up a new dish when we ask it to? Well, when it's time to actually generate a response, the process is less like cooking and a little more like weaving. So let's call this part the word weaver. So when you give it a prompt, the LLM doesn't think about what to say. No, it weaves an answer, one single word at a time. First, it breaks your prompt into little pieces called tokens. Then, based on everything it's learned, it runs a massive statistical calculation to predict the most likely next word. And here's the cool part. It tacks that new word onto the end of the phrase and then feeds that new, longer phrase back into itself to predict the next word after that. It's this incredibly fast loop that just keeps going, weaving a response together one word at a time. So just imagine the model gets the phrase, "the cat sat." What comes next? Well, based on all that training data, it calculates the odds. The word "on" might have a 90% chance of being the right fit. 8 is, well, it's possible, but much less likely. And flu? Statistically, that's almost 0. So at its heart, it's all just a very, very sophisticated game of probabilities. And this, right here, finally explains the large in large language model. Why does being big matter so much? It all comes back to those billions of parameters.
Having more of them creates what you could call a higher resolution of understanding.
Think of it like this. A model with fewer parameters is like a blurry, pixelated, low-res image. You can kind of make out the basic shape of an idea, but all the fine details are totally lost. But a model with billions or even trillions of parameters, that's like a stunningly sharp, high-resolution photo. It can see and it can generate really complex, subtle, and nuanced ideas with incredible clarity. That's why, generally, the bigger models are just more capable.
But, and this is absolutely crucial to get, these models are not perfect. They aren't thinking beings. At the end of the day, it's not magic, it's just math. And that math has some very real, very important limitations.
So one of the biggest and most famous limitations is something people call hallucination. Because the model is just predicting the next most plausible word, it can sometimes string together a sentence that sounds completely authoritative but is totally made up. It might confidently tell you that a certain Dr. Eris Thorne was the first software engineer on the moon in 1985. The thing is, that person and that event are completely invented, just because the words seemed statistically likely to follow one another. So it's super important to keep these weaknesses in mind. First, it is not a thinking entity. It is a statistical prediction engine. Because of that, it can hallucinate, confidently making up facts that sound plausible but have no basis in reality. And third, it can absorb and even amplify the biases present in the vast amounts of human text it was trained on. So if there's one thing to take away from all this, it's that LLMs aren't magic. They're just math. Math on an absolutely incredible, world-changing scale.